Hello, and welcome to this project on graphing probability distributions with R. I'm really excited to dive into this because for the first time in this class, we're going to be using R instead of Python to do some numerical analysis. So Python and R are both used in statistical processes. Anytime you have to do numerical calculations, you're going to use probably one or the other. R gets used much more frequently in probability theory, statistics, stuff of that nature. So we're going to switch over to R, and we're going to use RStudio to graph some probability density functions. So let's go ahead and dive right in. Follow along. I've already installed RStudio. Go ahead and do the same if you don't already have it installed. I'm just running RStudio 3.5, and we can go ahead and dive right in as soon as this gets started. All right, so here's RStudio. We have the console terminal. We've got our environment variables in the top right, as well as some of the files in our workspace. Our plots will show up down here as well. What I'm going to do is I'm going to open up a new project. So I'm just going to make a new directory, new project. Let's call this Unit 3 Projects, since that's what we are doing here today. All right, we'll go ahead and create that. And this will switch on over. Okay. So I don't just want to use the console and terminal. You can. However, it's not quite as convenient. What I'm going to do is I'm going to do a new R script file, and the output will print down here below. Our plot's actually going to show up right here. So let's go ahead and get started. Let's give this a title. What we're going to be doing is graphing probability density functions in R. And the example we're going to use today is plotting the normal, let's spell our words correctly, normal distribution of children's IQ scores, which have a mean of 100 and standard deviation of 15. So this is IQs. IQs have a mean of 100. Children have a standard deviation of 15. And the question we're going to ask today is what percentage of students, or let's just say children, have an IQ score greater than 115. And you can set this to whatever number you want. You don't have to do the same numbers as I do. The process will be the same. All right, we're going to start. We're going to define parameters of our distribution. So the first one is going to be the mean, and that is 100. The standard deviation is going to be 15. So here's the two parameters. The comments are denoted with the pound sign. Since we didn't put a pound, it's going to generate variables for us. We need to also define lower and upper bounds of region of interest. So this region of interest is going to be what we are looking at to answer this question. So the lower bound is 115, and we want to know everything above that. So upper bound is just going to be infinity. We want all IQs above 115. And then from there, we can generate sequence of numbers and make normal distribution. All right, so we're going to have X is going to be a sequence. We'll run from -4 to 4. Length equals 100, so we'll have 100 numbers. And we're going to multiply this by our standard deviation and plus our mean to shift this to the right 100. And then what we can do from there, if we just hit enter, go to new line, we'll generate our probability distribution using the command dnorm. So this is a normal density function, normal distribution, X mean standard deviation. So just generating a normal deviation over the sequence of numbers with a mean of 100 and a standard deviation of 15. All right, so that's that. Let's make a plot and add probability distribution and axis labels. So we'll get this going. First things first, let's have a plot, x and probability. Those are x and y. Set a type here, make this look nice. X label, we're going to set to IQ values. Y label, let's just call it P of X to denote that that's the actual distribution. And then the main here is going to be our main title. Let's call this normal distribution of IQ scores. All right, and the last thing's last, axis equals false. We don't need any axis labels right now, or axis tick marks is essentially what this is going to be. But this is just a plot. We have to add to this lines. Let's make a line plot over x with our probability distribution. And then axis, what we want actually is 1 at equals sequence 40 is our lower bound, 60 is our upper. Jump 20 each time, position equals 0, format that look nice. Alright, so we haven't been running this until now. Let's go ahead and do that now. You can run our scripts right from RStudio using Control-Shift-Enter. So if I hit Control-Shift-Enter, this will go. And you'll see it running here below. Your plot is going to show up here to the right. And any values or variables that have been defined are going to show up here in the upper right. So we have our normal distribution of IQ scores. This looks great. It's a perfect normal distribution. Our axis labels work great from 40 to 60 in 20 integer steps. And then all of our values are defined up above. So this is the plot of the distribution. Now we actually want to move on to answering the question, what percentage of children have an IQ score greater of 115? Let's go ahead and do that now. What we want to do is generate a polygon for region of interest so that we can plot this on our plot and we can see a nice graphical display of where we are looking at. What we need to do is define a new variable I, and I is going to be x is greater than or equal to, there we go, our lower bound, and x is less than or equal to our upper bound. And then we can go to a new line here, draw a polygon, C lower x of I, indexing of x, upper, and then C will have 0, probability of I, indexing for our probability distribution, and then 0 as well. Let's make this color equals red. Make it a nice red color here. Alright, so let's go ahead and plot this. So run Shift Enter again. And now you see we've added this nice red polygon denoting the region of interest that we're looking at on our normal distribution of IQ scores to the right. So that looks really good, clearly denoting what region we're looking at. But we haven't actually gotten a value back. So let's go ahead and look for that. We can calculate area under curve for region of interest and print results. That's exactly what we're going to be doing. So area is going to be 1, and 1, since this, what we really need to do is calculate a p norm here. So it's going to be essentially the integral, the area under the curve from our upper bound all the way to the left. Since our upper bound is infinity, this is going to be 100% or simply equal to 1. Since the integration of p of x dx from negative infinity to infinity is going to be 1, we can simply substitute in this 1 here instead of calculating this again. And then subtract from that p norm of our lower bound with mean standard deviation. So that's our area. Let's paste these results. And we'll do some formatting here. Lower IQ, comma, upper, equals, we'll have our last quotations there, and then we'll have sig and if area, comma, digits equal 3. So we'll go to 3 digits here. And then we'll make text, mtext result 3. All right, so let's go ahead and run this. Control Shift Enter. And we haven't found this actually. It's because I made an error here. I said results instead of result. Let's go ahead and run that again after fixing that. And there we go, works much better. And as you see, we've printed below here the probability of 115 and above is going to be 0.159. So this 15.9% of students are going to have an IQ score greater than 115. And that, I'm sure, makes sense to a lot of you. If you have a background in statistics, you understand the 68, 95, 99.7 rule. Since this is one standard deviation above, we could have calculated that intuitively from that rule. Feel free to play around with this. You know, what percentage of students have an IQ of greater than 145? If we run that, well, it goes significantly down, 0.001. So less 0.1% of students are going to have, or children, have an IQ greater than 145. It's easy to answer that question now that we've set up this distribution. We can do regions with upper and lower bounds, so 80 to 90. If we run this again, show the region of interest. And I believe this is actually wrong. This is wrong because we added this 1 here. So let's go ahead and fix that now. Upper, since we actually defined an upper bound, we got to recalculate that integral, and that's much better. 16% of students or children fall within this range. All right. I hope you were able to learn something from this project on graphing probability distributions in R. Thank you very much for following along and building this project along with me.